Okay, so we want to find and classify all stationary points for this function here. Okay, so we want to find any local minimums or local maximums. Okay, so what you're going to have to do is do a sign diagram of the derivative. Okay, so derivative would be, do 3x squared, because 3 comes down here, multiplied by the coefficient, and then the exponent reduced by 1, negative 2 times 3, which is negative 6, x, take 9. So that's your derivative. So to get a sign diagram of that, I have to factorize it. So I'd take 3 out of the common factor. It leaves me with x squared minus 2x minus 3. Okay, and if I was to factorize this here, factors are negative 3 that add to negative 2 would be negative 3 and 1. So it'd be x take 3, x plus 1. Okay, so this has a sign diagram like this. Critical values are 3 and negative 1. Okay, so I sub in different values to see what happens, and so let's sub in a value less than negative 1, which would be negative 2, so that would be negative 2 take 3, which is negative 5. Okay, and negative 2 plus 1, which is negative 1, so it's a negative times a positive, so that gives me a positive answer there. Okay, if I subbed in 0, I get a negative times a positive times another positive, gives me a negative answer. If I sub in a number greater than 3, like 4, I get 4 take 3, which is positive, times another positive, times another positive, so it's positive there. So I can see that the function is increasing here, decreasing here, increasing here. So that means the function's doing this. Okay? Okay, so I have a local maximum here and a local minimum here. But I haven't finished because I need to get coordinates. This tells me the x coordinates of this maximum. It does not tell me the y coordinate. It tells me the x coordinate of this minimum, not the y coordinate. So to get the y coordinate, I have to sub in this x value into the original function, not into the derivative. I sub it into the original function. So I'm going to do negative 1 cubed, take 3 times negative 1 squared, take 9 times negative 1 plus 5. Okay, that is going to equal 10. Okay, so I've got a local maximum at negative 1, 10. Okay, to find where the minimum is, I sub the minimum value, x value, which is 3, into the original function. Always sub back into this original function. So it becomes 3 cubed, take 3 times 3 squared, forgive my writing, take 9 times 3 plus 5. That gives me an answer of negative 22. So I have a local minimum at 3, negative 22. Okay, so that is finding and classifying all stationary points for this function.